All right, ladies and gentlemen, we're going to take a look at lesson 5.6, and lesson 5.6 has to deal with the quadratic formula. And that should sound familiar to you because we did work with this your freshman year. But as we take a look throughout chapter 5, we've learned two methods so far for solving quadratic equations. One method was factoring, and some of you recently worked on that when we were doing test fixes. But we have to figure out what values, what expressions multiplied to give me x squared minus 3x minus 10. So x squared's factors are x and x. A negative 10 is one positive and one negative. And then the factors of 10 are either 1 and 10 or 2 and 5. So a negative 5 and a positive 2 would give you that. And so as we take a look at this, we get x is equal to negative 2. Because if you remember, we're going to take x plus 2 and set that factor equal to 0. Or we get x is equal to positive 5, because we're going to take x minus 5 and set it equal to 0. So that's one way of solving. The other method we learned was square roots, where we undid our operations. So we go through and undo negative, or adding 24 by subtracting 24. And then we take the square roots. Because we're taking the square root, we include the positive and the negative square root. And that gives us 5. Now, I haven't just randomly given you quadratic equations. Each time I give you a quadratic equation, I made sure that if I was going to ask you to solve by factoring, that it could actually be factored. The ones that I asked you to solve using square roots, I made sure that they had no b values, that you could solve using square roots. But there can be sometimes that we can't use either one of those methods, and so we're going to need the quadratic formula. So I'm going to go to a split screen here so we can have those up. And we're going to take a look at those. The quadratic formula is x equals, so we've got that x equals, so notice we have both of those. The opposite of b, this is not negative b, this is opposite, and that should sound familiar because we've already talked about the opposite of b when we were working with lines of symmetry. Plus or minus in front of the radical should look familiar from up there. And then we have the square root of b squared. This is going to be in parentheses so that we're always going to get a positive value there when we square it. Because keep in mind, our calculator won't work well if we just do negative 2 squared. It has to be in parentheses. We then have minus 4 times a times c. And then all of this, notice that entire section is divided by 2a. So we are going to be looking at quadratics in standard form, which is why it was so important at the beginning of the chapter that we were able to identify A, B, and C. So let's take a look. This is in standard form. We don't have y equals, but we have it set equal to 0, and that's where our quadratic needs to be. It needs to be set equal to 0 for solving. And so we're going to go through and identify A, B, and C. So you have an A value of 1, a B value of positive 8, and a C value of 14. So we're going to have x equals, we're going to take the opposite of b, which is negative 8. The plus or minus is always going to be there, and so is the square root. So the things that are always going to be there, ladies and gentlemen, I'm kind of writing in the blue ink. And then I'm going to put my parentheses, and then it has to be b squared. So I have to plug in 8. And then we're going to have minus 4, and so that's always going to be a constant in our formula, times A times C. Let's see if I can move things over just a smidge. Times 1 times 14. The radical needs to be over all of that. And then we're going to always divide by 2 times, and then we're going to have the A value of 1. At this point, we're going to kind of work through that in order. We're going to do negative 8. We're going to have plus or minus, and we're going to have our square root, because we're going to keep our answers in radical form. This is going to be divided by 2. We did 2 times 1 is 2. What we need to now do is go to our calculators and type all of this in. And if we're being, let me see, efficient with our calculators, we're just going to type it in exactly the way it appears. We're not going to take it step by step. So I'm going to type in parentheses 8 parentheses squared, and then minus 4 times 1 times 14. I type it all in at once. I don't need to do it step by step by step. And that gives me square root of 8. Now when we look at this, ladies and gentlemen, we're back to a problem that is pretty similar to what we've seen before. We can go through and simplify. This is 2 times 4. This is 2 times 2, so we have a pair of 2's coming out. So let's talk about what this is going to look like. I've got negative 8. I've got, wrong color. I've got plus or minus. What came out of the radical was a pair of 2's. And then I have square root of. What's left underneath there is a 2. And then we're going to divide by 2. Now, when we first started studying radicals, so this is our answer, ladies and gentlemen. This is good. I can't add those because this is an integer with an irrational number with a radical. I can't divide them necessarily every single time. But I'm going to look at what I have here. I'm going to look at these values, the integer and the coefficient and my denominator. And I'm going to look and see, is there a common number that divides into all 3? So it needs to divide into all 3 of them. All right? And so when you look at negative 8, 2, and 2, these can all be divided by 2. So the simplified form of this answer is negative 4 plus or minus 1 square root of 2 all over 1. And as I'm sure most of you are sitting at home thinking, do we have to write those 1's? No. We're going to have negative 4 plus or minus the square root of 2. So I'm going to expect to see one of these 2 answers as we work through things. So let's go take a look at our last example here, ladies and gentlemen. I'm going to go to full screen. You have the quadratic formula on your notes. I have it memorized. So let's go through here. A little bit different than example 1 because it's not set equal to 0. We dealt with this when we were factoring. We're going to subtract 9x from each side to cancel it out. We're going to add 19 to each side to cancel it out. So now I am going to be equal to 0. And this is going to be 3x squared minus 7x plus 11. So what I'm going to need to do now is go through here, identify my A, my B, and my C, and fill in my quadratic formula. So A is 3, B is negative 7, and C is 11. So as I go through here, remember, x equals is always there. I have to take the opposite of B, so that's going to be a positive 7 this time, plus or minus the square root. You're always going to have parentheses, and it's going to be squared. So this is going to be negative 7 squared minus 4, I'm going to extend this, times A times A times C. This is then all divided by 2 times, and then we have our A value of 3. So what's in blue is what's going to be in every quadratic. What's in green is what we're going to add from our formula, or from our quadratic function. So as we go through there, remember guys, we simply go through and simplify what we can. This is 7 plus or minus square root divided by, and I'm going to call this 6. Now the reason I kind of jumped to my denominator is because I do need my calculator to type all of this in. So I'm going to go to my calculator and I'm going to type in parentheses negative 7 squared minus 4 times 1 times 11. 4 times A times C. And that gives me 5 there. Now when I look at this, I like this problem a lot more than what I've had before because 5 doesn't have any factors. It's prime. Nothing divides in here and never will as long as this is a 1. So if we have a 1 here, ladies and gentlemen, there's not going to be any simplifying. So here's my final answer. X equals 7 plus or minus 1 square root of 5 all over 6. So we're going to leave these in our simplest radical form. I do want to remind you guys, I am pretty bad at this, so I want to get better. You do have to keep your x equals in here. So these are x equals and x equals. So don't forget those as we go through and write our final answers. Okay? That's it for this evening. Have a good night. See you in class.